Waves. There are many kinds of waves: light waves, electromagnetic waves, waves in the ocean, and sound waves. Waves are the rising and falling of motion. When people think about waves, they imagine waves of water in the ocean. However, sound waves are not very much different than that. Sound waves also rise and fall just like in the ocean. All sounds are created by some kind of vibration. The definition of a wave can be described as a disturbance that travels through a medium from one location to another. There are two types of waves: transverse waves and longitudinal waves. Each of these waves are different in several ways. A longitudinal wave is a wave in which particles of the medium move in a direction parallel to the direction that the wave moves. A transverse wave is a wave in which particles of the medium move in a direction perpendicular to the direction that the wave moves. I'm going to start off by talking about transverse waves, what they do, and a few parts of them. This is a transverse wave. These are the four main parts that I'm going to be showing you. First is crests. Crests are the very top of the wave and the highest point. The second is troughs. It goes right along with crests as it is the very bottom part of the wave. Next is amplitude. Amplitude refers to the height, the overall height of the wave, from the very bottom to the very top. And finally, we have frequency. Frequency is the amount of times each second that a wave passes a certain point. So say we have a point here. It gets one click here, and then when this moves to here, it gets another click. And when this moves to here, it gets another click, and so on and so forth. That is how you determine frequency. Next, I'm going to tell you about longitudinal waves, and after that, how longitudinal and transverse waves work together to make sound waves. This is a longitudinal wave. Just like the transverse wave, this wave also has crests and troughs. And I think it's important to note that all of these little dots you see here are called air molecules. They are what the wave is traveling through, also known as the medium. As you can see, where the crests are, all of the molecules seem to bunch up, and where the troughs are, they seem to spread out. This has to do with a certain part of the wave called period. The period of the wave is how far each air molecule moves back and forth. This molecule might move this far back and forth, and it moves, which hits into another air molecule, which sends it going, and so on and so forth as the sound travels through the air. The period has a lot to do with transverse waves and longitudinal waves working together, and I will show you that next. Okay, so this is a graph of how the longitudinal and transverse waves work together. This is supposed to be a longitudinal wave. I couldn't find a really good one, so I tried to draw one. This is a longitudinal wave. It's moving parallel with the direction the wave is going. And this is a transverse wave. It is moving perpendicular, which means it is coming down this way across the wave. Now this is all to help you understand how the period works. The period is when the air molecule starts here as its position of equilibrium, and it moves all the way to the top and all the way to the bottom. That is amplitude and period. It's very hard to understand the two because they are very different. Amplitude determines the pitch, and period determines the length the air molecules move. So this air molecule will move to here, hit this one, and go back to here, and then return to its position of equilibrium, unless there is more sound waves coming. If there's only one sound wave, it'll only move once. And then this one will move and return back, and then this one will move. But as you can see here, they're close together, because this is when it has reached the crest of the wave, meaning it's closer together, so it doesn't go nearly as far here as it does here. Now, this is all really hard to understand, so I'm going to play a couple clips that I found of some people making an example of this, where they played sound through a tube that was burning fire, and you can actually see the wet crests and the troughs of the wave. So I'm going to play that next.